Alrighty, you might be wondering, where's the diagram, mate? We're doing mechanics. Sometimes they give you all this yap, and they'll require you to draw it yourself. Alright, guys? Can't be spoon-fed the whole time. I know you guys like to be spoon-fed. Too much watching Peppa Pig. Let's get to the maths. A particle of mass 5 kg is pulled on a rough horizontal surface with coefficient of friction 0.68 by a light inextensible string that makes an acute angle to the horizontal. Given the tension in the string is 60 newtons, but the angle in the string can vary, find the maximum value of the acceleration. All right, so we have a horizontal surface. We have some particle, and it's being pulled by some string, 60 newtons, but we don't know the angle of attack here. So we're going to write 60 newtons, and we're going to call this theta. Okay. What else have we got? We've got the 5g, the mass of the particle, and we've got its reaction force. It's mentioning acceleration, so the particle is moving. Now, we discussed friction in the previous video in quite a lot of detail, so go ahead and watch that video if you want to get more of an insight on friction. Now, because it's accelerating, the 60 newtons, of course, is going to be the stronger force here. Friction is going to oppose that. Now, because it's moving, friction has to be at its maximum. Now, we know F max is mu r. So I don't write F max here. I don't write F. If it's at its maximum, I'm going to write mu, which is 0.68, and then r. 0.68 r. So we obviously need to work out r first. But we also need to make sure that all forces are pointing up, down, left, right. So this, my adjacent, is going to be 60 cos theta, and this is going to be 60 sine theta. So dealing with r first, looking at the up and the down, r plus 60 sine theta, so these two added together equals 5g. So r is 5g minus 60 sine theta. All right. Cool. So there's actually a few boundaries we actually need to think about. I know they're saying the maximum value of theta. That's going to make sure that theta is small enough to make it big, but we also need to make sure that r is positive. Okay. And for that, I don't even know if we need to discuss that, because if you have theta is, just say, an extreme value 90, sine of 90 is 1. You're going to have 5g minus 60, which is going to be negative. But it wouldn't be accelerating that way. So I don't even think we need to consider it. We'll see in the future if we need to. Okay, but now looking at the left and the right, it's accelerating this way. So I always recommend to my students that you just write down which way we're accelerating, because now we're going to use F equals ma. Now, F equals ma is F net, the net force, the resultant force. Because it's moving this way, 60 cos theta is the larger value. Okay, and we're going to consider the situation where this is the larger value. To find the net force, we do the larger minus the smaller. So we're doing the positive force minus the negative force. So we're doing 60 cos theta, subtract 0.68 r, where r is 5g minus 60 sine theta. Okay, the positive force minus the negative force is the mass, 5, times the acceleration. And we're somehow having to maximize all of this. Okay, now we're going to divide by 5. And the thing about dividing by 5 is I can divide this by 5, which would be 12 cos theta minus, and I can actually divide both of these by 5. Pretend you factorize out the 5. You would have 0.68 g minus 12 sine theta is A. So we're going to have to expand that and kind of collect the like terms here, right? So 0.68 times 12. So I get 8.16. So I have 12 cos theta So this actually becomes plus 8.16 sine theta minus 0.868 g. 68 g. Is A. Now somehow we need to maximize this, which obviously we need to consider this. We need to find the maximum value of this. This is giving me our transformations vibes. Maximum and minimum values. Now, it's actually a lot simpler in terms of working out the form because you only need the R value. But I'm going to do the full thing anyway just to be a good teacher, innit? So, what form does it need to be in? It needs to be in the form of R. The first term is cos, so it'll be cos. Theta is the angle. Cos changes the sign, alpha. Now to work out R, we just do Pythagoras to the coefficients, 12 squared and 8.16 squared, which we'll type in a second. And alpha is inverse tan of the second number, 8.16 divided by 12, which I'll just round for this sake. So we have root 12 squared plus 8.16, which I'll put in a bracket, squared, 14.5, 14.511, etc. I'm going to store that value as A, just so I can use it later. This one I don't really care about. Inverse tan of, I'm doing a bit extra just so you guys get the full-on education in that. It's about 34.21. So we actually have that this is 14.51 ... and cos theta minus this 34.21 ... minus 0.68 g is A. Okay? Now if we want the maximum value here, what do we need to do? Should I do it here actually? We don't need this anymore. So to find the maximum value, it's actually very simple. You consider the cosine graph. You guys can answer this question for me. What is the maximum value of cos? Just cos theta. You should all tell me 1. Okay? So the maximum of cos theta is 1. So the maximum value of this is going to be the coefficient, which is that 14.51, because you're multiplying by 1, is that 14.51 ... minus 0.68 g. Okay? Now I stored this as A, so I'm doing alpha A minus 0.68 times 9.8. 7.84. Now, because we're using gravity, I'm going to say 7.8 meters per second squared. And that is your answer. And if they wanted to ask you, when does this happen? You'd think, okay, the cosine graph, when would this happen? I can just do a little bit of an extension for you guys. When does this happen? Well, we know when the cosine graph achieves the maximum. Here's the maximum 1 is at 0. So it's when you have this angle being 0. Cos of 0 would give you this. So it's when theta minus 34.21 is 0. It's when theta is about, let's just say 34 degrees. Okay? So when this angle here is at 34 degrees, it will be traveling at its fastest to the right. And that's a pretty cool question, guys. So what looked to be quite simple at the beginning ended up being a mazzoline. So, guys, if you learned something today, I'd really appreciate if you hit the like button, subscribe for more maths content, and if you're interested in my full A-level maths courses, more details are in the description, and feel free to join the Lung Gang Reddit page if you want to submit your own questions for the community to answer them. I'll see you in the next video. Nice.